Think of the last time you tried to change someone's mind with facts. You had the evidence, you had the logic. You were, by any reasonable assessment, correct, and it made absolutely no difference. If anything, they became more certain they were right. You probably assumed they were being stubborn, or foolish, or dishonest. Neuroscience has a different explanation, and there is a reason intelligent people are sometimes worse at this than everyone else. That finding comes later. What happened in that argument had almost nothing to do with logic. It was a threat response. The same neural architecture that protects you from physical danger was protecting them from the collapse of something more fragile and more vital than most people realize. A belief is a physical structure in the brain. When you hold a conviction for years, a political view, a religious commitment, an understanding of how the world works that you have carried since your 20s, that conviction exists as a network of neurons connected by synapses, distributed across multiple brain regions, reinforced by every experience you have interpreted through its lens. The physics of this reinforcement is specific. Each time the belief is activated, each time you think a thought consistent with it, each time you encounter information that confirms it, each time you defend it in conversation, the synapses involved undergo heavy and strengthening. Calcium flows through NMDA receptor channels. Additional AMPA receptors are inserted into the postsynaptic membrane. The dendritic spines enlarge. The connection transmits faster, with less resistance, consuming less metabolic energy per activation. Over years and decades, the neural pathway encoding the belief becomes heavily myelinated, wrapped in the same fatty insulation sheath that makes well-practiced motor skills automatic. A belief held for 40 years has been reinforced by tens of thousands of activations. The pathway is deep, fast, and efficient, a low-resistance highway through neural tissue. Challenging that belief is challenging, a physical structure that the brain has spent decades optimizing. The neural pathway for "I am the kind of person who believes this" is as real and as physical as the pathway for riding a bicycle. And dismantling it requires the same kind of sustained, repeated, metabolically expensive rewiring that unlearning any deeply practiced skill requires. Well, this is where most people's model of disagreement breaks down. They imagine a belief as an opinion, something held lightly, something that can be swapped out when better evidence arrives, the way you might update a phone number in your contacts. The physics says otherwise. A belief held for decades is infrastructure. The brain has built roads to it, insulated those roads, and routed a significant portion of its daily processing through them. Asking someone to abandon a 40-year belief is asking their brain to tear up a highway and build a new one, while still using the highway for every other cognitive function it supports. The metabolic cost of that restructuring is real and measurable. Building a new synaptic pathway requires protein synthesis, receptor trafficking, dendritic remodeling, and myelination, processes that consume glucose and oxygen at rates significantly higher than maintaining an existing pathway. The brain's energy budget is fixed at roughly 20 watts. Dismantling a well-established belief and building a replacement draws from the same budget that is simultaneously running every other cognitive function: attention, memory, motor control, language processing, threat detection. The brain resists restructuring the way any system resists dismantling infrastructure it depends on, because the resources required for demolition and reconstruction compete with the resources required for everything else the brain is doing. And there is a deeper structural reason the brain protects established beliefs. In network terms, a belief held for decades functions as a hub, a high connectivity node that connects to many other beliefs, memories, and identity structures. Removing a hub does not simply remove one connection. It destabilizes every node that connects through it. A political belief held for 40 years is connected to friendships formed around that belief, to media consumed through its lens, to decisions justified by its logic, to an identity built partly on its foundation. Challenging the belief threatens the entire network of connections that depend on it. The brain is defending the hub because losing the hub means cascading instability across the network. The stubbornness you observe in a political argument is the brain protecting its own network topology from cascading failure. Now, What happens when that infrastructure is threatened? In 2016, Jonas Kaplan and colleagues at the University of Southern California placed people in an fMRI scanner and showed them evidence that contradicted their deeply held political beliefs. The study was carefully designed. The contradictory evidence was factual, well-sourced, and presented without confrontational framing. The researchers were measuring which brain regions activated during a moment of contradiction, the precise moment when a person encounters a well-supported argument against something they believe strongly. What fired first was the amygdala. Within milliseconds, faster than conscious thought, faster than the prefrontal cortex could evaluate the argument on its merits, the brain's threat detection system classified the incoming evidence as dangerous. The amygdala is a small almond-shaped structure in the temporal lobe that evaluates incoming signals against a single criterion. Is this a threat? It processes that evaluation in roughly 12 milliseconds, a speed that predates language, predates reasoning, predates every cognitive tool the prefrontal cortex has developed across millions of years of evolution. The amygdala does not evaluate arguments. It evaluates threat level. And it classified a logical argument against a political belief as a threat to survival. Simultaneously, the default mode network became highly active, the same network that activates during self-referential processing, autobiographical memory, and identity maintenance. The brain was doing two things at once, detecting a threat and mobilizing identity defenses. It was treating the argument the way it would treat a physical attack, with identical urgency, through threat response circuitry, producing a downstream cascade indistinguishable from the response to physical danger. What follows from this cascade matters. When the amygdala fires a threat signal, it triggers cortisol release from the adrenal glands. Cortisol reaches the prefrontal cortex within seconds and suppresses its function, reducing the capacity for exactly the kind of objective, evidence-based reasoning that the argument was supposed to invoke. The person on the receiving end of your well-constructed argument became, in a measurable neurological sense, less capable of rational evaluation at the precise moment rational evaluation was most needed. The cortisol was suppressing the exact brain region that could have processed your evidence fairly. The amygdala shut down the jury before the case could be heard. This is hardware. The person who became more entrenched when you presented your evidence was experiencing a cortisol-mediated suppression of prefrontal function triggered by amygdala threat detection operating at 12 millisecond speed. They could not evaluate your argument because their brain would not let them. The threat detection system had seized control of the cognitive architecture before the reasoning system had time to engage. Let that land for a moment. The architecture that keeps you alive, that fires when a car swerves toward you, when a branch cracks in a dark forest, when any signal arrives that could mean danger. That architecture treats a challenge to identity with the same neurochemical urgency. It treats a challenge to physical safety. Identity for the brain is a survival structure. Threatening it produces a survival response. Now here is where the story gets more unsettling, because the next finding overturns the assumption that intelligence protects against this. Leon Festinger laid the foundation for understanding why, in 1957, when he published A Theory of Cognitive Dissonance, Festinger had done something remarkable. He and his research team had infiltrated a Doomsday cult in Chicago, a small group led by a woman who claimed to receive messages from extraterrestrial beings. The group believed the world would be destroyed by a great flood on December 21, 1954. The members had quit their jobs, given away their possessions, and gathered in the leader's house to await rescue by a flying saucer that would arrive at midnight. Festinger was interested in a specific question: what happens to a deeply held belief when reality unambiguously contradicts it? Midnight arrived. No flying saucer came. The flood did not happen. December 22nd dawned clear and ordinary. Festinger expected the members to abandon the belief. The prediction had failed as completely as any prediction can fail. They did the opposite. Within hours, the group had generated a new explanation. Their faith had been so strong that God had decided to spare the world. The non-event was reinterpreted as confirmation, proof that the belief had been powerful enough to change the outcome. Members who had been reluctant to proselytize before the failed prediction became enthusiastic evangelists afterward, calling newspapers and seeking converts with an urgency they had never shown when the prediction was still untested. The disconfirmation made them more committed, more vocal, and more certain. A prediction could not have failed more completely, and the failure made the belief stronger. Dissonance between the belief and reality was resolved by modifying reality rather than modifying the belief. Festinger formalized this. When a deeply held belief is contradicted by evidence, the brain experiences dissonance, a kind of cognitive discomfort that it is motivated to resolve. The resolution almost never involves abandoning the belief. It involves reinterpreting, dismissing, or reframing the evidence until the dissonance subsides. The brain seeks consistency, and when consistency requires choosing between the belief and the evidence, the belief almost always wins, because the belief is infrastructure and the evidence is a single data point. Dan Kahan at Yale Law School took Festinger's observation further and into territory that makes it personal. He spent years studying a specific question. Does greater scientific literacy and cognitive ability make people better at evaluating evidence on politically charged topics? The intuitive answer is yes. Smarter people, people with more scientific training, should be more willing and more able to follow the evidence wherever it leads. Kahan tested this directly across thousands of subjects on topics including climate change, gun control, and nuclear power. His finding, replicated across multiple studies and research groups, was the opposite of what anyone expected. Greater cognitive ability did not reduce motivated reasoning, it amplified it. On climate change specifically, Kahan found that among people with low scientific literacy, there was relatively little polarization. Both liberal and conservative respondents clustered near the middle. Among people with high scientific literacy, polarization was extreme. Liberal respondents were strongly convinced of the scientific consensus. Conservative respondents were strongly skeptical of it. The knowledge did not produce convergence, it produced divergence. The subjects with the best tools for evaluating evidence used those tools to construct more sophisticated cases for what their group already believed. Kahan called this identity protective cognition, the brain's tendency to process information through the filter of group identity rather than through the filter of accuracy. And the mechanism connects directly to the physics of the threat response. Intelligence provides more resources for constructing defenses. A more sophisticated prefrontal cortex, operating under the same amygdala-driven threat signal, does not evaluate evidence more fairly. It builds better fortifications around the threatened belief. The castle is the same, the moat is deeper. Evolutionary logic explains why this architecture exists at all. For most of human history, hundreds of thousands of years of living in small groups where survival depended on social cohesion. Being expelled from your group was a death sentence. Ostracism meant death by starvation, predation, or exposure within days or weeks. Holding beliefs that threatened group membership was existentially dangerous. The brain evolved to protect group identity as fiercely as it protects physical safety. Because for most of evolutionary history, they were the same thing. Losing your group was losing your life. The amygdala cannot distinguish between a saber-toothed tiger and a belief that might get you expelled from your tribe. Because for the brain that evolved to handle both threats, the survival consequences were identical. Logic arrived late in evolutionary terms. The prefrontal cortex, the seat of rational evaluation, evidence weighing, and objective analysis, is the most recent addition to the brain's architecture. It operates on top of a much older, much more powerful system that runs threat detection, identity protection, and social survival. When the two systems conflict, when logic says update your belief and the amygdala says protect your identity, the older system wins. Every time. In every brain. Including yours. You have experienced this yourself. You have held a position in an argument and felt the evidence shifting against you, felt the other person making a point you could not quite counter. And instead of updating, you dug in. The digging in was the amygdala overriding the prefrontal cortex. The cortisol was suppressing your capacity to acknowledge what some part of you already knew. The experience of being unable to concede even when you privately suspect you might be wrong is the experience of threat response. Hardware overriding reasoning hardware in real time. You felt it. You recognized it afterward. And you could not stop it while it was happening. Because the system that could have stopped it was the system being suppressed. The most counterintuitive result in this entire line of research came from correction studies. In 2010, Brendan Nehan and Jason Reifler gave subjects factual corrections to political misperceptions, clear, well-sourced corrections that directly addressed false beliefs the subjects held. The corrections were accurate. The evidence was strong. The methodology was careful. Among subjects who identified strongly with the political position associated with the false belief, the corrections produced the opposite of the intended effect. After receiving the correction, those subjects held the false belief more strongly than they had before the correction was administered. The correction had made them more wrong. Nehan and Reifler called it the Backfire Effect. The correction triggered a defensive consolidation. The brain, having detected a threat to identity through the amygdala cortisol cascade, reinforced the threatened structure rather than abandoning it. The physics of this makes sense in terms of neural network dynamics. A strongly activated threat response dumps energy into the threatened pathway, increasing its activation strength, deepening its Hebbian reinforcement, making the belief physically more robust after the challenge than it was before. The correction functioned as exercise for the belief. The challenge was the resistance. The belief emerged stronger. Subsequent research has refined the backfire effect. It appears to be more context-dependent than the original study implied, stronger for some topics than others, and does not occur in every condition. But the underlying mechanism, that corrections delivered as challenges to identity produce defensive entrenchment rather than belief updating, is robust across multiple research groups and methodological approaches. Every person who has tried to correct a family member at a dinner table has observed this. You brought the evidence, you were patient, you were clear, and you watched them become more committed to the thing you were trying to correct, their voice getting firmer, their position hardening, their willingness to engage shrinking with every fact you presented. You thought they were being stubborn. Their brain was running a threat response program that treated your evidence as an attack and responded by fortifying exactly the structure you were trying to dismantle. The more evidence you brought, the more fortification it triggered. You were feeding the very thing you were trying to starve. So what does it actually take to change your mind? The physics of that question has almost nothing to do with better arguments. Claude Shannon, in his foundational 1948 paper on information theory, gave a precise mathematical definition of when a system updates its model, when new information reduces uncertainty. A signal that tells you something you already expected carries low information. It confirms the existing model and produces minimal updating. A signal that contradicts a strong expectation carries high information. It represents a large deviation from the model, and, in a well-functioning system, produces proportional updating. The strength of the updating is proportional to the size of the surprise. That framework, updating proportional to surprise, is the foundation for everything that follows. Carl Friston extended it to the brain with his predictive processing model. The brain, in Friston's framework, is a prediction machine. It constantly generates models of what will happen next and compares those predictions against incoming sensory data. When the prediction matches reality, nothing updates. The model holds, the prior stands, the belief persists. When reality deviates from prediction, a prediction error, the brain must either update its model or explain away the error. The strength of the existing model determines how large the prediction error must be before updating occurs. A concrete analogy makes this tangible. Imagine a weather forecaster who has predicted sunshine for 40 years and been right every time. On day 14,000, one person tells them it might rain tomorrow. The forecaster rationally weighs that one report against 14,000 days of confirmed sunshine. The prior is overwhelming. The single data point is noise. That is Bayesian inference operating correctly. The forecaster would be irrational to abandon a 40-year model based on one report. Your brain does the same calculation with beliefs, using the same mathematics, reaching the same conclusion. One argument against 40 years of confirmatory experience registers as noise against the accumulated weight of the prior. And that is why your evidence did not work. The mathematics was on the side of their existing belief, and the prior had decades to accumulate its weight. Shifting a prior that strong would require either a single piece of evidence so overwhelming that it constitutes a prior-breaking prediction error, exceedingly rare in the domain of beliefs about politics, identity, and values, or a sustained accumulation of evidence over months and years that gradually shifts the posterior through repeated small updates. The first is what scientists call a paradigm shift. The second is what ordinary people call changing your mind slowly, over time, in a way you barely notice while it is happening. Every person who has genuinely changed a deeply held view knows what the second process feels like. The change did not arrive because someone made a good point in a conversation. It arrived because reality kept showing up in a form the old model could not explain, over and over, across months and years, until the accumulated prediction errors grew larger than the prior could absorb. The model broke. A new one formed. And looking back, you could not identify a single moment when the change happened, because it was not a moment. It was a gradient. You may remember the experience, a position you held firm in your 30s that you no longer hold in your 60s. You cannot point to the argument that changed it. There was no argument. There was a slow accumulation of experiences that did not fit. Moments where reality contradicted the model and the contradiction registered faintly, as discomfort rather than as a reason to update. The discomfort accumulated, the model strained, and eventually, without drama, without a single decisive moment, the model shifted, replaced by one that accommodated what the old model could not. The process took years. It felt, while it was happening, like nothing was happening at all. Only in retrospect did you realize the change had been underway for a long time before the old belief finally gave way. That is Bayesian updating operating on a biological timescale, not the instant updating of a mathematical formula, but the slow, metabolically expensive, structurally resistant updating of a physical neural network that has to demolish old infrastructure and build new infrastructure using the same limited energy budget. The mathematics says it should happen. The biology says it takes time. The experience of changing your mind, really changing it on something you held deeply, confirms both. So what does work? If logic and evidence trigger threat responses, mechanisms exist that bypass the amygdala's threat detection rather than confronting it. Paul Zach's research on oxytocin and narrative engagement identified one of the most powerful, story. Zach measured blood levels of oxytocin and cortisol in subjects before and after exposure to narrative content, personal stories with emotional arcs rather than argumentative presentations of the same information. Oxytocin rose measurably during narrative engagement, by amounts that correlated with the degree of empathy subjects reported afterward. Cortisol decreased. The neurochemical environment shifted from defensive to receptive through the format of delivery alone. When a person hears a narrative, a story with characters, tension, and emotional arc, rather than an argument with premises, evidence, and conclusions, the brain processes it through different circuitry. The default mode network activates in a mode associated with perspective taking rather than identity defense. Oxytocin, the neuropeptide associated with trust, bonding, and social connection, rises. Cortisol, the stress hormone that suppresses prefrontal function, decreases. The narrative format bypasses the threat detection system because the brain does not classify a story as a challenge to identity. It classifies it as social information, the kind of input the brain evolved to process collaboratively rather than defensively. Motivational interviewing, a clinical technique developed for addiction counseling and now applied across medical and psychological practice, works through a complementary mechanism. Instead of presenting arguments, the practitioner asks questions. open-ended questions that invite the person to examine their own position from the inside. Instead of identifying the error and correcting it, the practitioner draws out the person's own doubts, their own contradictions, the places where their stated beliefs conflict with their lived experience. The mechanism is specific. Questions activate the prefrontal cortex. The brain engages reflective processing to formulate an answer, which requires the very circuitry that an argument would have suppressed. The insight arrives from inside, surfaced by the person's own reflective processing, rather than imposed from outside through confrontation. The amygdala does not fire because no external threat has been presented. A question is an invitation, not an attack. The prefrontal cortex remains online because cortisol has not suppressed it. And the conclusion the person reaches, because it was self-generated rather than externally imposed, carries the neurochemical signature of insight rather than defeat, dopamine rather than cortisol, discovery rather than concession. The same information that would have triggered defensive entrenchment if presented as a correction produces genuine updating when it arrives as the person's own realization. Autonomy is the critical variable in both mechanisms. The amygdala responds to compulsion, to the sense that something is being forced, that a position is under attack, that compliance is being demanded. It does not respond to invitation, to the sense that new information is being offered for voluntary consideration, that the person retains full control over what they do with it, that their identity is not contingent on the outcome. The difference between an argument and an invitation is the difference between triggering the threat response and bypassing it entirely. The content can be identical. The framing determines whether the amygdala fires. You have seen this work. The conversations that actually changed minds across your lifetime, yours or anyone else's, were almost never the ones where someone won the argument. They were the ones where the other person felt safe enough to wonder aloud, where a question was asked rather than an answer demanded, where the person was invited to look at something from a different angle and chose to do so because the invitation carried no threat, where the insight arrived as their own thought, surfaced from their own experience, connected by their own default mode network, delivered through their own reflective processing, and landed with the weight of something discovered rather than something conceded. Neuroscience does not make stubbornness forgivable in every situation. It does make it comprehensible. And for a person who has spent decades frustrated by the immovability of other minds, frustrated by family members who will not hear the evidence, by friends who dig in when challenged, by a world that seems to choose belief over fact with maddening consistency, comprehension may be the most useful thing the science has to offer. The brain was never built to follow evidence wherever it leads. It was built to survive. And for most of the time brains have existed, survival meant belonging to a group, and belonging to a group meant believing what the group believed. Logic was always the junior partner. The amygdala was always running threat detection underneath every rational conversation either of you thought you were having. I have thought about this for a long time, about why the experience of being right and being unheard is one of the most universal human frustrations. The neuroscience does not resolve the frustration. It locates it. The frustration sits in the gap between two systems that were never designed to work together. A reasoning system that evaluates evidence and a survival system that evaluates threat. Every argument you have ever lost was lost in that gap. Every argument anyone has ever lost was lost in that gap. The gap is the architecture. The architecture is the same in every brain. Think of that argument you lost, the one at the beginning. You were right, your evidence was sound, your logic was solid, and none of it mattered. Because the brain across from you was running threat detection software that classified your argument as an attack and shut down the only system that could have evaluated it fairly. The person did not choose to be irrational. Their amygdala chose for them in 12 milliseconds before their prefrontal cortex could even begin to process what you were saying. The cortisol arrived seconds later and completed the suppression. By the time they were responding to your argument, they were responding with a brain that had been neurochemically reorganized to defend rather than evaluate. You have done this too. You are doing it now, somewhere in your belief architecture, about something you hold deeply enough that the amygdala would fire if the right evidence arrived in the right form. Understanding this does not exempt you from it. The amygdala fires faster than understanding can intervene, but understanding it changes what you do with the next conversation. It changes what you expect from an argument and what you offer instead. The argument you lost was lost before it started, because the architecture that would have needed to process your evidence was suppressed by the architecture that detected your evidence as a threat. You were speaking to a prefrontal cortex that had already been taken offline by an amygdala that had already classified you as dangerous. Next time you want to change someone's mind, the neuroscience says, ask. Tell a story. Let them arrive at it themselves. Give the amygdala nothing to fire at, and the prefrontal cortex might stay online long enough to do its job. That is the physics of persuasion. And it has almost nothing to do with being right.